Hi, so our project is three-color ZKP. First, before you do anything, you have to run make to make our prover and verifier executables. And after you run make, you want to run the commands / verifier. You can specify the port number that you want and the number of repetitions. And so repetitions is just the number of times the protocol between the verifier and the prover is run. And so higher repetitions would mean an increase in confidence on the verifier side that the graph is three-colorable. So we can do 100 repetitions on the verifier side, and we press run, so that will start the server. And then on the prover side, you want to run the following commands. You specify the address localhost, specify the port number, which is the same one as the server. This right here, we made a directory of example graphs to play with. And so for this one, I'm going to do a improper three-colored graph. So if you run this command, it would fail about a third of the time, because about a third of the time, the verifier would choose an edge that has the vertices the same color. So we can run it again, and yeah, it would fail about a third of the time. And we can also do a graph that's actually three-colorable. So let me do a proper graph. Let me do a Peterson. And you can see that all 100 repetitions passed. And you can increase the number of repetitions to like quite large. It can be like 1,000,000 if you want.
This is our code base. I'll walk through it. So our project produces two binaries, of course. It produces the prover and the verifier. So we have that under cmd/prover and cmd/verifier. Briefly, each of these runs is just a simple main function. We've abstracted a lot of the networking code, so like the code is like quite readable here. So we can see, for example, the prover creates a new TCP connection, sends the graph, receives the number of repetition, and here is just like the protocol that we cover in class. And we see a similar thing with the verifier, except instead it receives the graph and sends the repetitions, and then does the verifier side of the protocol. We created a separate library for graph. So here we have a package called graph that essentially has this graph data structure that contains the vertices and the edges, and we have some helper methods to just query the vertices and edges and see if like a vertex and an edge exists, for example. And we also have code here to parse a graph. So how this works is that we have a lot of graphs over here that are in a file format that we created. So they're easily representable in a TXT file. So for example, this is a Peterson graph. We supply like all the vertices here and all the colors, and here are like the connecting edges. So this code, this function right here just parses that and creates the graph from that, and also creates the graph and also the coloring. But of course, the prover keeps this coloring a secret. And then in our party package, we have, so this part is like the common messages between the prover and the verifier, and we have some special methods to send and receive, because we wanted to abstract away the serialization and deserialization part. And then in party, this is just like common functionality and structs between both the prover and verifier. Both need to like know how to commit. They need to have the same lambda parameter, and also they both need to know the existence of an open commitment. And the prover and verifier are each their own struct with some various functions to make the main function of the prover and verifier easier. So here we go. So like, for example, here's like the verify function that just checks if the hash and commits are the same, the colors are different, and the colors are one of the 3 accepted colorings, which we've defined as red, green, or blue. So yeah, that is our code base. Thank you.